Assalamu alaikum viewers, welcome to my channel Genome Wide Study. If you are new on my channel, please subscribe and press the bell icon so you will get the notification of all the new videos. But don't forget to like this video. So this is the video part 6 of our Genome Wide Study analysis, and in this video we will try to learn that how we can collect the protein sequences for constructing the phylogenetic tree, because phylogenetic tree study is very important too for our genome wide analysis and for the prediction of the function of our protein family. And now number 2 is the which protein sequences used for that phylogenetic tree construction. So for collecting the protein sequences for phylogenetic tree, we will use different methods. Number one, directly we give the name of the gene in the NCBI, and then we can take the its protein sequences as we have done in finding the Curie proteins for our that HMA analysis. So likewise, first we try to give the name of the gene in the NCBI and then take out the protein sequences. But sometimes we can't find the gene sequence by giving its name in the NCBI. In that case, we should have the NCBI ID or transcript ID of that gene. So that how we can find the NCBI ID or transcript ID of that gene. So we will also try to do this method in this video. And then if the sequence of that gene from the referred paper. Number one, we have to find it from the NCBI by giving its gene ID or transcript ID or like this, or also some paper have that give the sequence of that gene and that was present in the supplementary data of that paper. And secondly, that what type of sequences we use for the phylogenetic tree. Number one, we use the studied crop sequences of the protein family of the studied crop. Like in our case, we are working on the HMA protein and in maize. So one is our HMA protein members from the maize. Another one is from the model plant. The HMA protein sequences are your studied protein family from the model plants. In our case, the model plant is Arabidopsis. So maybe you are working on bacteria or animal sciences or entomologist, so you can use your own model organism. And the third one is the sequence from the closely related species, that you are working on any organism or crop or plant or anything, so you try to find the of your protein, sorry, the protein family members from your closely related species. For in this example, I will choose the rice. You can use any other according to your crop. And also the fourth one is the family members or the protein sequences of that genes that were functionally characterized, whose function was experimentally proved. So we can also try to find out that genes and also insert in that phylogenetic tree, and through that genes we can predict the function of our family genes. So how we can apply all these methods? Let's start. So this is our folder of that analysis, HMA analysis in maize. So I have made the folder named sequences. So we already have the that Curie protein, the ATHMA1, and we have downloaded from the NCBI during lecture 3, and these are the protein sequences of our crop. So we make a new file, named it seek for phylogenetic tree. Open it. So first we copy the protein sequences of our crop, control C, and paste it. Now we also copy the C and paste it in that file and save it. So we have the protein sequences of our curie protein, our model plant, and also our crop plant. One, now we have to find out the protein sequences of HMA protein sequences of a closely related species, that is in our case that we have choose the rice. So simply go to the Google, open the NCBI, and first you must know that how many genes, HMA genes, are your family genes in that closely related species. So I want to know that how many HMA genes present in the rice. So click click PubMed, write genome wide analysis of HMA. So here you can see a lot of papers. So you can open any one. So this one we can open, or this one. Open the whole complete paper by clicking on it. When it comes, so you can find simply in here, it may be mentioned that 9 in rice. Here it means in every crop how many they have. The 8 in the rubbed up says the 9 in rice. So we know that there are 9 genes, HMA genes in the rice. So we will try to find out one by one all these by simply, hopefully we will find by giving it their names, like here select protein and then OS HMA1. So here you see that we can't find its by giving its name, or we can also change the name HMA1 in rice. So by giving this name, so we have find out that this is the HMA1 in Oriza. So simply apply the same method, FASTA, and this protein sequence, copy the protein sequence of HMA1, go to the file that we have generated for phylogenetic tree, at the bottom, greater than OSHMA1, enter, control V, enter, then OSHMA2, and right here again HMA2. So here we have also got this HMA2. Click on FASTA, paste, then greater than OSHMA3. So in this way you can try to find out all the 9 HMA from the Oryza sativa. So after getting the all the protein sequence, HMA protein sequences of that Oryza sativa, now we will try to find out the characterized, functionally characterized genes, HMA genes sequences. So again right here the PubMed, and write genome wide analysis of HMA protein family, and also open any latest paper that was maybe in 2024 or like this, or here you can also click 2024. That was easy, so you can open the complete paper. Now first method is go to their phylogenetic tree and check whether he has used other genes, means characterized genes or not, different crops, AHGM like this. Then you need to check its supplementary file. Maybe he has given the names of the genes or sequence of that gene. So drop down, and here is the supplementary file. So you need to click here and save it. Save it. Now open the folder and check whether it has given the that supplementary table. You can check what he has given, because some papers they give the sequences of protein sequences of different genes in their supplementary material. If they have given, so it is easy for us. If he didn't given, then we can find out another paper or another method. So here it didn't give, so we'll leave it. Maybe here it is the figures. In this way you can find out any paper to get the sequences. If you didn't find any paper, then you can go to the paper introduction and then see that what if he mentioned any other crops, family genes, like here we see, here is mentioned the 80 that we already have. Here OS that we already have downloaded. Here is another one that no, this is HMA. Then go to the, if you didn't find in the introduction, then go to the discussion section. Discussion, he also didn't mention any other paper, any other gene from any other crop whose function was already characterized, or you can check its references. If you didn't find in this paper, then you can check any other paper. This one, sodium vulgar. Here you see that he has mentioned HVHMA1 its function. So we try to find out the if sequence of this sorry, gene. So first method, we try to write here that protein and HVHMA1. So we found it that HVHMA1 in harmful gear. So simply FASTA and copy and then HVHMA1 paste. Likewise, we try to find out another one. If we can't find the through this way, then we have to go to that reference paper. This is a reference paper. Then open this paper. This is the second method. PubMed, enter, open that paper. Then you can find the transcript ID or gene ID that was given in the here, that they have given the ID of there in a material method, or sometimes they have given the ID NCBI ID in a introduction, sorry, in results or in the supplementary material. So you can find out that ID, or sometimes given the transcript ID of the gene. So you can take that ID and then paste into the NCBI, and then you can collect the sequence of that protein. So in this way you try to add more and more and more characterized proteins, or simply you can also get other genes related to here, like you can get heavy HMA genes function. So here you can find the in plants heavy metal. You can say take any paper and then you can check out. Here you see that CSHMA4 and CSHMA3 we have also, we have to try to take the sequence of these two genes, CSHMA3 and CSHMA4. So simply back, so go back, select here protein and write that name, which one paper that we have, CSHMA3 and CSHMA4, CSHMA3. So here is, we have got the sequence of CSHMA3, and also we can write CSHMA4 faster. So we can copy CSHMA3, CSHMA4, so if we didn't find these sequence through this method, means writing name, then we have to find out that through that NCBI ID or the transcript ID. So in this way you can find out the characterized genes sequence. So I have already also download the sequence from 2 HMA2 and 3 from Triticum STWAM, 4 from BJ, HMA4 from AH, HMA3 from NC, and from different crops by finding these characterized genes through their paper, or from most important, if you want to check So you can find any review of literature written on that protein family. In that review of literature, you can find out the maximum number of characterized proteins. So you can take their name and then find out the sequence by either giving their simply name or finding the NCBI ID or transcript ID and then give it into the NCBI and then take that sequences. So we will use these protein sequences to constructing the phylogenetic tree. So in the next video, we will construct the phylogenetic tree by using these protein sequences and make them grouping that how we can divide these protein sequences into different groups and also give the name to our that Xiaomi's HMA that which name we have to give on it HMA 1, 2, 3 according to their fall are closely related characterized genes. So see you in next video. Don't forget to like, comment. Thank you.